that's just the way it goes. My sound is not working for my YouTube through my laptop, so I cannot show you this awesome, cute little YouTube video. But if I were to show it to you, it would say something along these lines. That I think you're pretty convinced that galaxies, most galaxies have a supermassive black hole in their center. Maybe, maybe not, but they do. Ours does. The Andromeda galaxy has a supermassive black hole in its center as well. When the black holes, and it's not working now again, when the black holes are feeding, you gotta be kidding. Actually, they create this energy signature called a quasar. But what Fraser Cain would have explained is that quasars are actually this energetic event we call a quasar, very energetic, supermassive black hole in a distant galaxy is feeding. What does that mean? Well, it's what it sounds like. Basically, a star has gotten too close and it's being pulled in. The next slide, you're going to actually see something called an accretion disk, which we've talked a lot about accretion disks in here. Basically, stuff is kind of in queue to fall into the supermassive black hole. They didn't always know what quasars were. It's only been like the last 20, 30 years that scientists have gotten together and kind of decided that's what they were. Quasars were more likely to exist at the early part of our universe. These are actually, this slide is also related to a supermassive black hole feeding. They're just different energy signatures of the same event. So radio galaxy, same thing as a quasar. And it's thought that actually such an event, if the energy were directed in the wrong or the right place, actually, and we were in the line of sight, this is one way that our whole solar system could be sterilized, just in kind of the blink of an eye. It's a positive thought for the day. So what you're looking at here is the supermassive black hole in the center. You see an accretion disk, matter kind of in queue to fall down. Then you see these jets of energy kind of spewing out on either side. So we talked in here earlier that when matter is far away from the center of gravity, it has a lot of potential energy. And as it gets closer to the thing it's orbiting, in this case, the supermassive black hole, its potential energy decreases and its kinetic energy increases. And so that's actually what that accretion disk, that's how it gets its energy. So its energy actually, not its energy. As matter crosses the event horizon, remember we talked about event horizons when we talked about black holes around stellar black holes. Supermassive black hole also has an event horizon. When matter crosses that, actually it's releases a lot of energy according to Einstein's equation. This is actually looking at a distant galaxy and looking at the red and the blue shift in stars as they orbit the supermassive black hole in the center of that galaxy. Remember, one of the things that how did we come to find out that Sagittarius A star is a supermassive black hole? It's by looking at the orbit patterns of stars. And so we do that with other galaxies too. So last slide, in this chapter anyway. So each one of these white dots actually is a supermassive black hole in a distant galaxy. And it just simply says, we talked about features of galaxies, and one of the features of galaxies is their central bulge, especially if they're a spiral galaxy and they have a disk component to them. But not so surprising, the size of the central bulge, or the mass of the central bulge, directly correlates pretty well to the size of the supermassive black hole in its center. A little bit of play on that red line, but pretty good. So that's probably not so surprising. So